Welcome to the video where we are going to dive into split linked list in parts. So basically in this array we receive as input a linked list and we are supposed to split the linked list into k parts in such a way that there is no input, like there is no subarray having a difference with another subarray more than one. So here we have 4 elements and here we have 3 elements. The difference is 1 element, so it's okay. If you find yourself with an array with maybe 5 elements and another array with 3 elements, there will be a problem because you have a difference of 2 elements. Okay, so that is interesting. So for us to solve this, how are we going to approach it? Since we know that we want to have an array as equal as possible, the first thing we will do is that we are going to compute the length of the linked list. That means the number of elements of the linked list. Once we are going to have it, the next thing is that we are going to divide it by k, and that indivision is going to return the minimum number of elements that should be in a sublist. And then after applying the applying the size modulo k, we're now returning the extra, and the extra are going to share from the first until where we will not more be able to dispatch extra. So what does that mean exactly? That means for this one, for instance, if I have 10, this 10 is going to be the size of the linked list. 10 divided by 3 is 3. That means I'm going to have 3 per sub linked list. And then now 10 modulo 3 is 1, so I have 1 extra, and that 1 extra is going to go to the first element. If I had another extra, it would have gone to the second element and so on. So let's dive into the code. The first thing we need to do is to have the linked list size. So I'll just call int size. I will just say I definitely need another guy here that is going to be equal to my head, and I'll say while c is different for null pointer. What I will do here, I'll just say since I'm counting, I'll just increment this. So I definitely initialize this as 0, and then I'll just say c now equal to c dot next. So at the end of this, I have the size of my linked list. So now that I have the size of my linked list, what I should compute now is the minimum number of elements that the sublist can have. So it's int me, I'll call it me, that is going to have s divided by k. And then I have the second element that is actually extra, which is going to be s modulo k. So here I have my two variables. Now what I should now create is a vector of linked list, which is going to be my result, and I'm going to call it result, and this is what I will return here. So now the next thing to do is to construct each of the element of my result array. So how many elements do I need to construct? So I need to construct k elements, so I can just have a loop here, moving from there on. Okay, and each of the element I'm going to construct is actually like a linked list. So I'm going to have like a list node of, I will call it like let's say cur if I want it, node pointer, and then I will have something like cur end. That means the end of my linked list. You understand why I need this? And this is going to also null pointer. Nice. Now that I have this, what is the next thing to do? So basically I have a pointer to this element, and then I know that each of the elements is going to have either the minimum, which is actually me, or me plus 1. That means me plus the extra. So if we have at least one element to the extra, that means this guy is going to have me plus extra element. Otherwise, this guy is going to have just me element. So that's what we are going to do. So for that, we are just going to have another for loop here, moving from 0, g less than me plus, this is rest, I will call it not rest, I call it extra here. I call it extra greater than 0 e plus plus. So what is happening here is that I'm saying I'm moving from me plus extra greater than 0. If extra is actually greater than 0, that means this is going to return true, and this true is going to be evaluated as 1. So I'm going to have the me plus 1. Otherwise, it's going to return 0, and it's going to be evaluated as 0. It's going to return false, which is going to be evaluated as 0, and this one is going to be equal to me. So one thing interesting is that now I'll directly loop using head, because I will not need to use it again at the end. So what I can do is that I can directly have my check here on head. If I have head, because it can be empty, if I have head, I will just create now my list node, which is going to be my new node, which is going to take new list node. I missed something, I know that, of head dot val. So I'm missing one thing, which is this star here. And after each operation, what will happen is that the head is going to take head dot next, and then yeah, I'm just gonna say if, it's really important to do this, if actually this guy, the cur, is actually equal to null pointer. Why am I saying this? Because it's really important to realize that if the current node is actually equal to null pointer, you cannot access the next element. Only if the current node is actually a valid element that we can access the next element. And then here you understand why we needed the end pointer, because when the element is actually null, what we are going to say, we are just going to say the current is going to take the new node that has been created up here. Is going to take the new node, and then the cur end is going to take the cur. So here we have two elements pointing to the same guy. It's just like we have two elements here, and it's just the cur, I would say the current is actually the element that is going to be append to our vector, whereas the cur end is actually the element which is going to loop until we will be at the end of the element we can add. So you do agree with me that with that explanation, in the else, what we will do is that we're just going to say the cur end is going to take the new node. No, it's not this one. The next is going to take the new node, and the cur is going to take dot next. And at the end of all this operation, we need to reduce our extra. So we're just going to have extra minus minus, and then we're going to have result dot push back off. Okay, I hope my logic is clear. I hope there is no error. This should be okay. Let us want to see what it gives. Okay, we have an error. What has happened here? Head we take head dot next here. We have a wrong answer. What has happened? We had this input with 3, and the guy returned us 4 here, and that's all. Okay, instead of okay, who's the guy moving? Cur end. This is a big error. So this is actually cur end, and this is cur end, because you want your cur, like I explained at the beginning, you want your cur to just point the head, and you want the cur end to move. Perfect. So this was my approach of solving this. I hope you do enjoy it. Feel free to give me any input. I'll be really happy to interact with you regarding this. See you on the next video. Ciao.